Good morning, students. So today we are going to discuss some basic fundamental about the trusses, and we will be doing one problem with method of joints. So what are trusses? Trusses are studied in engineering mechanics. It is a special kind of a structure which is used because it is very practical and economical when we are going to have a large scale coverage of some area. So trusses are used mostly like in bridge, in roof. You must have seen on the railway platform that there is a kind of a structure below the tin sheet that is basically the trusses. If you'll see the bridge from the side view, you will see a special kind of a structure, some sort of triangles formation that is basically the trusses. It is most economical and practical, that's why it is used and it give a good strength. Now in the starting of the mechanics we used to see application of free body diagram and equation of equilibrium with the use of trusses. Say all the members on the trusses are straight members. They are joints at their extreme ends. They are jointed at their extreme ends only. Okay, there is no in between joint, or you cannot have a member uh, which is passing over a joint and continued. So all member are joint at their extreme ends. Members are slender and can support little lateral load. That means most of the members, you'll find some members are horizontal, but most of the members are inclined, slender. And they cannot carry vertical loads, so loads are implemented only at joints. So even in some problems, if you'll find that force, the weight of the members has been given, then you have to divide it in two portion and pass half of the weight to the right support and half to the left support. So that is what members are not supposed to take any load. There is no load is to be implemented on members. It is only implemented at joints. So forces are implemented in joints, and each of the members of the truss is a two force member. That means every of the truss we consider is under equilibrium because of application of two force. There is no couple, no movement. So members can have either tensile force or compressive force, and they can transfer the force like you see that there is a pipeline, and pipe in the pipeline water is flowing. So there can be either direction one way or another way, but it cannot be that you cannot have water coming out of pipes. So there is it is only the transfer is along the pipe. So that is what force is transfers along the members. It can be a tensile force or a compressive force. Now, what are the forces in members? There are two kind of forces we consider. One is the tensile force and second is compressive force. So, if we see that this is a member of a truss, so if we will take this joint separate and this joint separate, so remaining portion, if we'll see the tensile, that is having tendency to elongate the member, then arrowhead on the joints are going to be as per Newton's third law. It is member is pushing the joint, the joint is pushing the member, so arrowhead on the joint is away from the from it. So if we have to assume tensile force in a member of truss, we assume the forces on joints away from the joint. So that is what when we have to assume tensile force in any member, we do not show this, but we show this and this. So that means if we show arrowhead is away from the joint, that means we have assumed tensile force in the member. We are not going to show four arrows on a member, but we are going to show only forces on the joints. So arrowhead away from the joint means tensile force, and opposite to this, if arrowhead is towards the joint, it is going to be compressive force. Member is under compression, so compression means it is going to have a tendency to reduce the length. So it is going to be like this. This is wrong. This is going to be like this. I show you. This should be like this. Okay, so it is under compression. Member is reducing in length. arrowhead towards the joint means a compressive force. This is general assumption we do use when we analyze the forces in a truss. Tensile means away from the joint, compressive means towards the joint. Let us proceed further. There are now, normally they ask, people used to ask in the question paper, what are the different type of trusses. So trusses can be defined majorly on the based on rigidity. M is equal to 2j minus 3, where M stand for number of members and J stand for number of joints. We are assuming that there is a reaction, there are three there are two supports and you have three reactions. So you'll have M is equal to 2j minus 3, where 3 is the number of reactions. Also somewhere people may use this. If M is equal to 2j minus 3, that means number of members is equal to 2 times number of joints minus 3. Then the truss is just rigid, that is, it is able to take the load which is implemented on it. If M is greater than 2j minus 3, it is over rigid, that is, number of members are more than required. M is less than 2j minus 3, it is under rigid. That means if we implement the force, truss is going to deform under the such conditions. So normally when the question is given in any of the paper, truss is given as a rigid truss. So we are supposed to study or analyze the rigid truss only. Now based on application also we can classify truss as roof truss and stadium truss, bridge truss, etc. So we are proceeding with method of joints now. What is method of joints? There are three methods to analyze the truss. The first method is method of joints, second method is method of section, and the third method is graphical method. Normally nowadays people teaches method of joints and method of sections. Graphical method is not in much use, and the most of the people are in fact comfortable with method of joints. Method of section is little bit tricky, but it's a good one. So method of joint is based on principle of equilibrium of particle, whereas method of section is based on principle of equilibrium of rigid body. So at a time with method of joints we can solve two unknowns, and in method of section we get three unknowns. So there are certain advantage and limitation of method of joints and method of sections. But let us proceed with a simple question on method of joints, and I have taken this question from the very reputed book of Shames, that is solved example 6.1, just to illustrate how method of joint is to be used. So let us proceed further. This is a truss given to you, and in this truss what you are having, this is a roller support. You see this is a kind of a truss. It is all triangle, but not necessary that always will get a triangle. Okay, remember that you may get rectangle or different kind of shapes, not necessary that you will always get a triangle. Second thing is the angles. You see these angles, the angles in this figure, the angles are you see here, they are same, they are same. Okay, because this is 8 and this is 12 and this is 6. If you'll see the dimension, the angle are going to come same. Okay, you calculate tan theta or sin theta, it is going to be tan theta is going to be 8 by 6, sin theta is going to be 4 by 5, and cos theta is 3 by 5. But it is not necessary that angle will be given to you directly. Sometimes they may give you angle directly to you. Angle may be 60 degree, 45 degree, or sometime you may have to calculate the angle from the given data. So do not assume yourself angle. Be very clear at the starting that what are the angles given in the truss. If it is not given, calculate it before the starting of the question. So we will see how method of joint is implemented stepwise. Here the truss is A, B, C, D, E, where C is a hinge joint and D is a roller joint. The dimensions and the forces, there are two external forces acting here, 2000 and 2000 and 1000. It is 2000 I suppose. So there are 2000 and 1000 force acting here. This is 2000 is acting here. The first and foremost point to analyze a truss is we have to calculate the support reaction, except in cantilever truss. Cantilever truss will put another video later on. So uh, in most of the trusses, in all the trusses, in fact, the first step is going to calculate the support reaction at hinge and roller support. Or if even sometimes they try it, instead of the support, they can give you a something like a rope or or a chain there, so you have to find out tension there. Okay, so that is find out external unknown which are acting on the truss. So for this purpose, we have to assume the complete truss and one rigid body. Try to assume this as a one rigid body. This is completely one rigid body. Okay, assume this one solid, and then try to see that there are hinge support two unknown, roller support one unknown. We have taken. You can take any direction. We have taken here this and this. You can take any how you want, and then you try to implement. Assume this is a big block. Forget about that there are small members. Assume this is a big block and try to implement three equation of equilibrium: summation fx0, summation fy0, and movement about a point is 0. The symbol normally what we use and is a standard, that is summation, already the same is used, same in been used in same has been used in summation fx equation also. So the first in the Shames and other standard author. So the first one is taking summation fx0, taking rightward direction as a positive direction. Summation of movement is equal to 0, taking movement about point C. Anti-clockwise is taken as positive, clockwise is taken as negative. Summation fy is equal to 0, taking right upward as a positive. So we have seen the first equation, Cx is equal to 0. There is only one horizontal force in the truss. Summation of movement about C. So we'll take movement about this. Try to see what is the perpendicular distance of 2000, that is going to be this much. Perpendicular distance of 1000 is going to be this much. Perpendicular distance of EY is going to be, if you'll extend the line of action, it is going to be this much only, that is 6. So we have to see that whether it is clockwise or anti-clockwise. Accordingly we have to fix the directions, and by solving these three equations we are able to calculate three unknowns: ey, cy, and cx. So cx is 0, cy is coming 10,000 upward, this arrowhead is showing upward. 7,000 is coming as negative, so we are taking it as because we have assumed it upward, so that means it is the opposite direction, that is downward. Now let us proceed further and go to step number 2. Now step number 2, we have diverted a little bit from the concept which has been given in the Shames. As we are just trying to and assume forces in all the members. So we assume tensile force in all the members. That means we assume arrowhead is away from all the members at all the joints. So what we have to do, we have seen see the nomenclature is special here. You can write f1, f2, f3, etc., but this is a conventional one. Force at A because of V, FAB. So if you see the opposite force of this, which is acting at joint B, it is force at B because of A. It is force at B because of C, force at C because of B. Like this we have given nomenclature of all the forces which are acting on this. Now interestingly, you should understand that FAB and FBA is going to be same. They are going to be same in magnitude but opposite in the direction. So let us proceed further, and next step is going to be now you have to select a joint with having only two unknowns, because every joint is a particle, and a particle can be under equilibrium by summation fx0 and summation fy0. That is no movement along x-axis, no movement along y-axis. So we have picked up joint A. We can select any other joint. We can select joint C also. It is anyhow you can start, but move systematically. So we'll select the joint A, make the free body diagram of A. Now what is it? It is interestingly the way we have done it, we can make small circles all around these joints, taking care of all the forces which are here. So it is going to make, basically you have already obtained free body diagram of all the joints with this step 2, and it is very easy to identify that which joint is having two unknowns. So let us proceed with joint A, and you see here now you write summation fx0, summation fy0. It's very easy, you can write it, resolving the forces horizontally, vertically. Even you can use Lami's theorem if you want. to solve this equation or find out these force FAB and FAD. Now remember this, that FAB and FAD, maybe it is coming positive and negative. The meaning of positive is what we have assumed is right, that is FAD is a tensile force, and if FAB is coming as negative, that means it is not a tensile force, it is a compressive force. So we have to take it as a negative sign. But if it is coming a positive or negative, we have to carry forward the same sign throughout the question without changing the sign. We can proceed with free body diagrams of all these joints and try to see, solve the question. Do not change the sign in between, but the meaning is clear that FAD is a tensile force and FAB is a compressive force. You can say negative of tensile, that means become positive of compressive. Now next step is going to be, you go to next joint which is having two unknowns. So we can go to joint D, because D you have calculated this force, this is going to be same as this without change of sign. Keep it well in mind, you are not going to change sign anyhow anywhere throughout the question. So whatever is the value of FAD is going to be the value of FDA. Now we'll go to joint D and try to see, there are two unknowns, this and this. We solve for these unknowns and then proceed to next joint. Likewise, we have to move from one joint to another joint till we reach the next last joint. So let us proceed to next joint. So this is joint number D. We have written summation fx0, summation fy0. See carefully that we have put the sign intentionally the same. Whatever sign we have got for FDA is going to be FAD. The same with sign is to be carried forward. No change in sign. We have obtained further value of FD. The unknowns we have obtained, there were two unknowns we have obtained with these two equations, summation fx0 and summation fy0. Vertical upward is taken positive, rightward is taken positive, and similarly once we have done joint number joint D, go to the next joint, and we have to continue to all the joints unless we solve all the things. So we'll go to joint B, see the equations, write the equations of equilibrium. Okay, you can make it yourself. Rightward is positive, leftward is negative. Do not change arrowhead, do not change sign, carry forward with same. Write the equation first as per the free body diagram. Write the equation first and put the values within bracket if it is negative or positive. जो भी value, whatsoever value you are getting, positive or negative, same is to be kept in place of this with proper sign. No change of sign is needed. So we have done for joint number B. Then we go to joint E. Make the FVD, write fx fy. You see here I have intentionally written this clearly. Write the, make the free body diagram, write the equation, put the value then with sign, okay. Similarly here, okay. Now when you are coming to this joint, you have FEC already obtained from here above equation, you can check your answer should come as 0. And when you go to the last step, which is not necessary, but it's make you sure that you have done all the things right. You have to go for summation fx0, summation fy0 on the last joint. If it is coming 0, that means your all answers are right. So this is how you can apply method of joints to solve the problems. I hope this is clear. Finally, when you represent the answer, you can make a table in this form. You can write member, force and nature. So you can write, now you can remove the sign, you can say what is the amount of force. If it is coming positive sign, you say tensile or you say compressive. I hope this video is helpful to you and you have clear with method of joints. If you want any other help, you can write to me. I will be sharing more videos so that you can learn and implement the method in other questions. Thank you all listening to me.